Okay, I want to start this off with the laws of logarithms. Okay, it's very, very important. Anytime I'm dealing with logarithms that are being added or subtracted or multiplied by a constant, they can all be written as log of a single thing. Alright, so if I add log plus log and the bases are the same, which they will be, they're not going to throw weird things with different bases in it right now. So log base b of m plus log base b of n, you multiply the m and the n to create a single logarithm. For example, if I had log base 3 of 6 plus log base 3 of 7, that would be log base 3 of 42. Instead of having a sum of logarithms, I can make a single logarithmic expression. That's very, very important in these logarithmic equations. You want to get log of something. You don't have pluses and minuses in the problem. So, you start off with plus or minus, you can combine them together into a single. If we're subtracting the logarithms, it's basically the same idea, except now you divide first by the second. So if I have log base 17 of 49 minus log base 17 of 7, that's going to be log base 17 of 7. Alright? So, log, single log expression, base stays the base, and then 49 divided by 7 equals 7. Alright? The third one, if you have any constant being multiplied by a logarithm, that constant becomes the power of the logarithm. So if I have 9 log of 4 base 12, that's going to be log of 4 to the 9th base 12. Any constant in front of a logarithm becomes the power of the argument, whatever 4 to the 9th is. Hopefully it won't be that big of a number. All right? And finally, part 4 is the most important part here. Once you've taken a sum of logs to make a single log expression, or a difference of logs to make a single log expression, or a number multiplied by log to make a single log expression, you get log of something equals log of something, then argument 1 equals argument 2. Okay, that's going to be the key to these problems. Getting the logs out of the problem. Once log equals log, argument equals argument, left over is going to be a basic algebra equation that we can solve very easily. So the best way to deal with these, I think, is to actually watch a problem being done. Each one of these scenarios that happens, example 1 is a plus, example 2 is a minus, example 3 is a multiplication by a constant. So all 3 of these scenarios happen. All 3 of these lead us to this last one. This happens in every single problem. Log 1 equals log 2, argument 1 equals argument 2. So, example 1. Log base 3 of x plus 7 plus log of 2 base 3 is equal to log of 20 base 3. First off, it's going to happen every single time, but it's just a verification thing. All the bases have to match. If they don't, it's going to be a different kind of problem. At this point, they're going to match. When you get to geotrig, if you choose to take geotrig next year, they'll start off matching, and then down the road they won't match, but we'll know how to deal with it then. All right? It's slightly more difficult, not a lot more difficult. All right. So, I see the right-hand side is exactly how I want it to be. I want every side to say that, log of something. I don't care what the something is as long as it's log of something. There's nothing extra going on. There's no number in front of it. There's no addition or subtraction. The left-hand side, though, has more than one log in it. That's no good. The left-hand side has to be fixed here. Law number 1 says if I'm adding 2 logarithms, I'm supposed to multiply their arguments. So I create a single logarithm, log base 3. I'm going to multiply argument 1 times argument 2. That's a binomial times a monomial, so distributive property. That's going to become 2x plus 14. So again, I'm applying the rule. The rule says to multiply this thing times this thing. And since this thing's a binomial, the distributive property says I have to distribute. 2 times x is 2x, 2 times 7 is 14. The right-hand side is going to stay exactly as it is, log of 20 base 3. So that's my first priority. I want to get the equation to look like this. Log of some object equals log of some other object. Once I get to this point, log equals log, that means argument 1 equals argument 2. And once argument 1 equals argument 2, I just have to solve that, which is really basic, right? Move the 14 to the other side, we're going to get 2x equals 6. And finally, divide by 2, we get x equals 3. Here's the one extra added feature for logarithm problems. It's a requirement of logarithms. I don't know if you've noticed this enough as we've been doing this, but here's the domain of a logarithm. Log of x base b. X has to be greater than 0. That's the domain of a logarithm. Every problem we've done at this point has been log of a positive number, right? We've never seen log of 0. We've never seen log of negative 55. Okay, domain of a logarithm is positive. All right. So the one extra added feature on a logarithm problem is once you get the answer, go back to the original problem and verify that this number creates all positive arguments. I don't care. It does. You don't have to check to make sure it works. You simply have to make sure here's an argument, here's an argument, here's an argument. Make sure this thing doesn't create any negatives up there. What's 3 plus 7? 10. Which is positive, right? All right, that's good. There's no x, so these are positive. They're set, right? So the only thing that this answer is affecting is only the first one here. 3 plus 7 is positive 10. You get all positive arguments, it's the correct answer. If you get any negative arguments, you throw it out and you empty set it. All right? But if it's all positive arguments, that means your answer is good. Circle it and move on to the next problem.